object starts from rest and acquires a velocity of 10 meters per second in 2 seconds. We have to find the acceleration of the object. We have the formula acceleration equals delta V over t. Now delta V is change in the velocity. So the final velocity v minus initial velocity u over the time t. The final velocity is 10 meters per second and initial velocity is 0 since the body has started from rest. So we write this as 10 meters per second minus initial velocity 0 over the time t, which is 2 seconds. We can cancel out 10 by 2 5 times, so we are left with 5 meters per second squared. A body is moving vertically upwards. Its velocity changes at a constant rate from 50 meters per second to 20 meters per second in 3 seconds. What is its acceleration? Now, this question wants us to find the acceleration of the body which is moving vertically upwards. Now let's imagine the body was initially at this position and finally reached this position. Its velocity changes at a constant rate from 50 meters per second to 20 meters per second. So from this sentence we understand that the initial velocity of the body is 50 meters per second and the final velocity of the body is 20 meters per second, which is v equals 20 meters per second. From this data here, we have to calculate what is the acceleration of the body in 3 seconds. We have the formula acceleration A equals change in velocity over time. Change in velocity is nothing but final velocity minus initial velocity over the time taken t. The final velocity is 20 meters per second. So we write 20 meters per second minus the initial velocity, which is 50 meters per second, minus 50 meters per second. And we have to divide it by the time it has taken, which is 3 seconds. If we simplify this, we get minus 30 meters per second upon 3. Now if we cancel the 30 with 3, we get minus 10 meters per second squared. Now this is the acceleration of the body. Now notice that we have got the minus sign here, which represents the negative acceleration, also known as deceleration or retardation. So the body is moving with a constant retardation of minus 10 meters per second squared. A car is moving with a velocity of 20 meters per second. Brakes are applied to retard it at a rate of 2 meters per second squared. What will be the velocity after 5 seconds of applying the brake? So this question wants us to find the final velocity of the body after going through a retardation of 2 meters per second for 5 seconds. So what we do first is we write the data down given from the question. Is moving with a velocity of 20 meters per second. So the initial velocity u given to us is 20 meters per second. Brakes are applied to retard it at a rate of 2 meters per second. So acceleration equals minus 2 meters per second squared. Now why I have taken the minus sign here is because it is retardation. Retardation is the negative of acceleration. What will be the velocity after 5 seconds of applying the brake? The time given to us is 5 seconds. We have the formula acceleration A equals final velocity minus initial velocity divided by the time t. So we substitute all the values here. We get minus 2 equals the final velocity which we have to find minus 20 meters per second 20 divided by the time, which is 5. Now if we take 5 on the LHS, we get 5 times 2 gives us minus 10 equals final velocity minus 20. If we take the 20 on the left hand side, we get positive 20 minus 10 equals final velocity v. 20 minus 10 gives us 10 meters per second, and that's the answer. A car is moving in a straight line with a speed of 18 kilometers per hour. It stops after 5 seconds of applying the brake. We have to calculate the speed of the car in meters per second, the retardation of the car, and the speed of the car after 2 seconds of applying the brake. This question wants us to convert the speed of the car from kilometers per hour to meters per second. So we know that 1 kilometer equals 1000 meters and 1 hour equals 3600 seconds. So to convert kilometer per hour into meters per second, we have to multiply 18 into 1000 upon 3600. 1000 cancels 3600 5 upon 18 times, and then 18 cancels out 18, so we are left with 5. This means 18 kilometers per hour equals 5 meters per second. That's the answer. This question wants us to find the retardation of the car. So we have acceleration equals final velocity minus initial velocity over time t. Acceleration A equals, because the car stops after 5 seconds, the final velocity must be 0 minus the initial velocity, which we found in the previous question as 5 meters per second. And the time given to us is 5 seconds. 5. So the acceleration would be minus 5 over 5 meters per second over seconds. 5 cancels out 5, so we are left with minus 1 meters per second. So the retardation of the body would be minus 1 meters per second squared. This question wants us to find the speed of the car after 2 seconds of retardation. From the previous solutions, we have got the initial velocity of the car is 5 meters per second and the retardation was minus 1 meters per second squared. So we use the formula acceleration A equals final velocity minus initial velocity over the time t. So we substitute the values of u and a in this equation. We get minus 1 equals the final velocity v minus the initial velocity, which is 5 meters per second, over the time, which is given to us as 2 seconds. 2 seconds. So we cross multiply this, we get minus 2 equals final velocity minus 5. So on further simplification of this equation, we get 5 minus 2 equals the final velocity, which gives us 5 minus 2 equals 3. So 3 meters per second, and that's the answer.